All right, in this video, we are going to talk about descriptive measures for populations. So in a previous video, we talked about the sample mean, right? And to go back and review about population sample, remember the population is the entire group of individuals under study. So for instance, maybe you have, you want to find the average height of everybody in the United States of America. That would be your population, right? And then remember what a sample is. A sample is a smaller part of your population, right? There would be, if you're interested in finding the average height of everybody in the United States, there's just way too many people to go and measure. So what you would do is just take a representative sample of people and then measure their heights, right? So some smaller part. That's a reasonable thing to do. So population is everybody in the entire group under that you're studying, and then a sample is a smaller part of your population. And we already talked about the sample mean, right? Remember, you can take lots of samples, right, of a given size from a population, right? So there's only one population, but lots of different samples that you could take. Lots of different ways of choosing a smaller part of an entire population. And so this, if you take a sample, right, of size n, then the sample mean is given by the following formula. Remember, the notation for the sample mean is x bar, right? That's the x with a bar over the top, and that's the symbol that we'll use for the sample mean most of the time. And if you're using another variable, though, it would be whatever the variable is with a bar over it. And how do you calculate the sample mean? Well, you just add up all of your observations. Remember, that's what this Greek letter sigma means. And so add up all of your observations and then divide by however many you have. Okay? And that will give you your sample mean. All right, we can also think about doing that for the population mean. And remember, there's only going to be one population mean, right? The population is everybody, right? And there's just one group. That's everybody who is in the study. And so there's only one population mean, whereas with the sample mean, you have, the sample mean would be different for if you took a sample in different ways. And remember, there's a bunch of different ways to take a sample. So there would be lots of different sample means, but only one population mean. The population has its own symbol, and that is the Greek letter mu. All right. The Greek letter mu is written in English, right, as mu, like this, mu. So mu. And it looks like this, which most people kind of think of as either a U or a funky looking M. I think it's actually better to think of it as a funky looking M, right, because of the fact that it stands for the mean, right? So that is the Greek letter mu, and that is the symbol that's used for the population mean. And the formula for the population mean is exactly the same as it is for the sample mean. In other words, you do exactly the same things. What you would do is add up all of the observations, every single observation in the entire population, and then divide by the size of the population, assuming that it's a finite population, which it will be for the things that we talk about. Okay. So, and then you would divide, right, the sum of your observations by how many are in the population. For the population, we use a capital N to represent the size of the population, whereas with a sample, it is a lowercase n. Okay? So again, just to reiterate, there's only one population mean. There's lots of different possible samples that you could take, right? And each of those possible samples has its own sample mean involved. All right, so here we want to take the population. It's a really tiny population, right? And so we want to take the sample mean. So let me write down these observations, 2, 5, 0, and -1. Right? And the population mean would be the sum of the x sub i's divided by n. All right, and so we would just add up the observations, 2 plus 5 plus 0 plus minus 1, and then divide by the number that we have, which is 4. Okay, so that would come out to be 7, 6, right, over 4. So the population mean is 1.5. Okay. So really and truly, there is the calculations are exactly the same for a sample mean as it is for the population mean. But remember, you have to remember the idea is different, right? The population mean, there's only one of those. Sample means, right? There's lots of different possible samples. Each one of those sample means would have a different mean. So you have lots of different possible sample means. Okay. Now you may say, well, if it's exactly the same, why why do you bother going over that? But remember, they are two different things, and for the mean, it doesn't make a huge difference, but it's going to be different for the sample standard deviation. Okay. So we talked about the sample standard deviation in a previous video, right? The symbol for the sample standard deviation is a lowercase s. Okay, and here are the two formulas that we talked about. And this first formula is how it's defined, right? And in the second formula is the formula that I said I prefer this formula for making computations with. To me, it's easier to make the calculation. You can use whichever one you want, it's fine, but I highly recommend using this second one here. It's just less steps involved, and therefore you're less likely to make an error, in my opinion, by using the second formula. Okay. So we already talked about this in a previous video. I'm not going to talk about it a huge amount here. Okay, so in the next slide, we also have a population standard deviation, right? And the population standard deviation, you'll notice a couple of things are different, right? The one thing that's different is this symbol that we use for the population standard deviation, and that is it's sigma. So this is a lowercase Greek letter sigma. It kind of maybe looks like a cursive S that you would write a little bit. That's a Greek letter, right? The lowercase version of the Greek letter sigma. All right, and so that is the symbol that's used for the population standard deviation. And just like before, there are two formulas, okay? And those two formulas look an awful lot like the formulas for the sample standard deviation, but you'll notice that they are not exactly the same, okay? Over here, right, you'll see that in the first formula, right, it's the sample size minus 1, whereas in the population standard deviation, it is capital N, which is the size of the population. So that is a frequently asked question about why do you use the actual size of the population in the population standard deviation, but in the sample, went the wrong way. In the sample standard deviation, you use the sample size minus 1. All right, and again, that is because, right, of the nature of what we are going to be doing with samples and population, right? We talked about inferential statistics, and that is when you have a population that's so large that it's not really feasible to go out and survey everybody in the population. But what you want to do is to take a sample, right, find a smaller part of the population and let them take a survey. And you want to use the results from that survey to make decisions about the population, right? And so it just turns out that that if you use the sample size minus 1 in the population or in the sample standard deviation, it turns out that the information that we get from the sample standard deviation, it just better reflects the population standard deviation. All right, so it's kind of hard to explain that point at this point in the course. But that's basically the reason why. Here in the population standard deviation, right? This, remember how if you go back and look at the sample standard deviation, how I talked about that, then I said that this part in here reflects the distance that each observation is from the mean. Okay, in this case, the population mean mu. And so what we're doing is we are really taking kind of the average or the mean of those deviations there, okay, in for the population. All right, so again, there's two formulas. This formula is how it's defined, and this formula is a computational formula. Again, I much prefer this formula over the other one when I'm going to compute those out, and I will always use this one, okay? All right. So in the next slide, what we want to do is compute the population standard deviation for that for this population here, right? 250 minus 1. So going back, right, to our formula, remember it is sigma equals the square root of the sum of the xi squareds divided by the population size minus the population mean squared, right? So we're going to use that formula to compute the population standard deviation. Okay. All right, so I'm going to list out my exabytes, right? Again, this is a very small population, but that's okay. Just enough to get the idea of how to compute this. And so this calculation, we would basically do the same things that we did in the sample standard deviation calculation, right? We would square each of these, right? So 2 squared is 4. 5 squared is 25. 0 squared is 0. And minus 1 squared is 1. Okay. And then we would add all of those up. And that looks like it comes out to be 30, right? 29 plus 1 is 30. And so that number would be the sum of the x sub i's squared. Okay. All right, and then we would punch all that into our formula. So the sum of the x sub I squared is 30. The size of the population is 1, 2, 3, 4. And the mean, population mean, mu, is 1.5. Okay. Okay, and then what we would do is just punch that into the calculator. Remember, do not round these intermediate calculations off because of the fact that that if you do that, you are going to get some error in your calculations when you do that. All right, so putting that in here, we get this value, 2.291, and let's just give the answer to 3 decimal places. Like I said, in the quizzes and on the test, they will tell you how many decimal places that they want you to display the answer. Okay, and so that's how you would calculate the population standard deviation. Okay, so the next thing is to know the final thing, right, in this section is to know the difference between the word parameter and the word statistics. Okay, so a parameter is a descriptive measure for a population. So the ones that we talked about so far were the population mean mu, that's the mean of the population, and the population standard deviation sigma, right? So those would be considered parameters because they are descriptive measures for a population. And then what a statistic is a descriptive measure for a sample. So for a sample, right, that would be x bar, right, the sample mean, and s, that's the sample standard deviation. Those are statistics because those are for a sample. All right, and again, the main focus, especially on the second half of the class, will be, you know, the fact that you normally will not know what the parameters are, right? There's just usually the populations are too big, right, to get a handle on those. But what you can do is use statistics, right, to give approximation of those parameters, right? You would take a sample, simple random sample, right, and then try to use those statistics, right, to estimate and make decisions about the population parameters. Okay. All right, I believe that is it in this video, and so we will leave it there.